Welcome to 6-Minute Statistics, where we take one topic at a time and try to explain it in simple and straightforward language that is surprisingly easy to understand. And we try to do it all in 6 minutes. Today's topic, probability distribution. Two words you probably understand individually, but find somewhat confusing when I put them together. No worries, that's my job. So you want to learn about probability distributions? Let's go.
Give me 6 minutes and I'll teach you something new. Now, let's get to work.
Mark here from 6-Minute Statistics. And as we see quite often in statistics, before we can move forward, we have to look backward. To understand what a probability distribution is, we need first to think back to our discussion of random variables. I define them as variables that assign values to the various outcomes of an experiment. The first example I used was trying to keep track of the number of students that had a tattoo. I asked each student in my sample whether they had a tattoo or not. They could simply respond either as yes or no. Simple enough. That is, until you start putting all the combinations of yeses and nos together. That's where a random variable comes in. The random variable was defined as the number of the students in the sample that did have a tattoo. In the example I looked at, there were 5 students that were sampled, so the values of the random variable x went from a minimum of 0, and then 1, 2, 3, 4, and all the way up to 5, a total of 6 different outcomes. We talked about how this was a great example of what we call a discrete random variable. I need to mention here that the ideas I talk about in this video with regards to probability distributions work for both discrete and continuous random variables, continuous being the second type of random variable. The big difference is that the math gets much more complicated when we're working with continuous distributions and really isn't necessary for your understanding. You know one of my mottos, keep it simple, student. Well, we're going to apply that here and limit my conversation to probability distributions working with discrete random variable. And while I'm thinking about it, a big shout out to the student who suggested I make that my next tattoo. Great idea. Maybe if and when this whole YouTube thing gets monetized, I'll consider it. Let me know your thoughts in the comments. But I digress. Back to the topic at hand. Random variables assign the values of x that we're interested in. It's the probability distribution that gives us the probability of observing the various values of x. There are 2 rules that must be followed for a probability distribution to be considered valid. The first is all the probabilities assigned have to be between the value 0 and 1. In probability, a value of 0 means that value of x cannot occur, and a value of 1 would mean that value of x must occur. Usually probabilities are somewhere in between, especially since the second rule says that the sum of all the probabilities assigned by the probability distribution must be 1. Probability distributions can be expressed in a variety of forms. Some of the more common methods are tables, graphs, or formulas. I'll show you what a table looks like in a tattoo example that I'll work with here. Let's suppose there's a 30% chance that a student has a tattoo, and I randomly sample 5 students from across the country. Let's walk through what the probability distribution looks like for the values of x, where x represents the number of students with a tattoo. We start with our 6 values, 0 through 5, and I'll write them in a column. The probability distribution now comes behind me and fills in the various probabilities for the values of x. In this example, the chance that all the students have a tattoo, 5 students, so that would be the probability x is equal to 5, is found by taking the probability a student has a tattoo, the 0.3 or the 30%, and multiplying that by itself 5 times. It's 0.3 to the 5th power, or 0.00243. The chance that none of the students have a tattoo, similar argument now, except instead of the 0.3, we're going to take 0.7 to the 5th power, and that probability, the probability x is equal to 0, is 0.16807. I'll use my statistics skills to fill in the rest of the probabilities in the table for us. To understand a probability distribution right now, it's not important for you to see where these probabilities come from, only that they are all between the values 0 and 1, and that they do sum to 1, which they do in this case. This is, in fact, a valid probability distribution. Now, I know that will drive some of you nuts. You have a burning desire to know where I got those probabilities from. If that's you, I recommend you go back and take a deeper dive into the outcomes I talked about in my probability videos, or take a look at the binomial probability distribution in the videos I made and take a look at that topic. If all you need to do is determine if the probability distribution is valid or not, all you want to do is check those two rules. Make sure the probabilities are between 0 and 1 and that they sum to 1. Notice it really doesn't matter what the values of x are. It's just the probabilities that matter. We next will look at some of the more common probability distributions and where they come from in statistics. But that is for another day and another video. For now, get comfortable identifying when the two probability rules are met. And don't forget to like this video and subscribe to my channel. That'll help me get closer to my YouTube goals and maybe even closer to a not so good looking tattoo in my near future. Until next time, so long, and it's time to get to work.